Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy, and welcome to another Trig on Tuesday. I've been doing some work with these guys lately, slide rules, and I thought that because these are basically logarithmic number lines, I thought I'd go over logs and scientific notation. So let's cue up the music and have some fun with math. Now, I've been doing a little bit of math recently, and I've gotten some feedback from some high school teachers that I was teaching some bad habits, and I agree with that. I was getting a little bit sloppy with a couple of things in math, and I thought that I would go over them in this episode so that we all kind of were on the same page. Well, first of all, let's talk about something called significant digits. Now, one of the problems that I ran into when I asked people to calculate the distance above the surface for a geosynchronous satellite is that I didn't pay as much attention to significant digits as I should. So I want to bring that up right now. So let's look at a couple of numbers. The first one is 1. How many significant digits does 1 have? Well, it's got 1. What about 23? Well, we've got 2 significant digits. 101, 3. How about 1,000? Trick question, because these zeros don't count. We only have 1 significant digit right there. Now, why does this 0 count? Because there's another number to the right of it. That indicates that we have measured this number to 1 part in 100. And since we don't know if those 3 numbers are accurate, we say that they're not significant digits. We're pretty sure on that one. Now, here's where the significant digits come into play. Say we've got 2 numbers, 2.5 and 11. 2.5 has 2 significant digits. 11 has 2 significant digits. So since the maximum number of significant digits that we're working with is 2, can we be confident in a 3 significant digit number? Well, in science, probably not. We would probably have to report this out as 280 for the simple reason that we're going to have to disregard this last digit, or perhaps round it up, because we can only really be confident in these first 2 digits. This third one is beyond the significant digits that we were working with. So here's the problem. Perhaps my scale was only accurate to 1/10 of an ounce. And if I actually measured 11 samples at 2.5 ounces each, and then I weighed all 11 samples, maybe I'll come up with 278. So like I said, these 2 numbers we're quite confident in, because we've got 2 significant digits that we're working with up here. So we're confident to 2 significant digits in our answer. We can make an educated guess to that last one, but that number there really doesn't count like these 2 do. Now, let's have a look at scientific notation. Now, no matter what this number is over here, we can express it in a power of 10, with the one exception of 0. 0 has no power of 10 that you can bring it to. When you raise something to the power of 10, to 0 times, that means that you're just dealing with single digits, between 0 and 9, but not including 0. Now, when you're dealing with 10, you're dealing with 1.0 times 10 to the power of 1. So basically, whatever you have here, you multiply it by 10 to get the original number. Same thing with 100. That's 1 times 10 to the power of 2. 1,000 would be 3. A couple of reasons that this is important. First of all, it really cuts down on the number of zeros you have to write for really big numbers. Second of all, when you deal with one of these things, a slide rule, this is a logarithmic scale. Now, a slide rule, it only has an accuracy of 2 significant digits. You can make a scientific wild-ass guess on that third one, kind of like we did here. But we don't really have as much confidence in that as we do in the first 2 digits. So what we like to do is write something in the form of x decimal xx. And then we multiply that by a power of 10. We can raise it to other powers, but we're going to stick with power of 10 right now. Now, something that used to be very commonly taught was logarithms. Now, what's a logarithm? Now, when we write something in scientific notation, we'll write it in the form of something like this: x.xx times 10 to the power of 2, say. Well, we can express that a little differently. We can use something that's called a log base 10. Now, there are other bases that we can use. We can do log base 2. We can do log base e. But this is what's called the common logarithm. It's base 10. So if you don't see anything written there, you can simply assume that this is all dealing with base 10. So let's put it back here real quick. Where do all these numbers fit in? First of all, that goes there. So whatever you're raising to a power is your base for your logarithm. Second, this number goes here. And third, your exponent comes down here. Now, why go through all of this? Well, let's go over a couple of the rules of logarithms. Now, here are a couple of principles of logarithms. First of all, every number except for 0 has a logarithm. For example, every number between 10 and 100 has got a logarithm between 1 and 2. So you take all of the numbers between 10 and 100, figure out the logarithms for those, and they'll come between 1 and 2. And I've given some examples right here. I'm sorry, I just noticed I made a little mistake on the board, but I've corrected it now. So let's take three numbers: 0.5, 50, and 500. Now, in scientific notation, they're all 5.0 times 10 to the negative 1, because we've had to move over to the right of that 0, times 10 to the 1, because in order to make this 5, we've got to move the decimal over to the left 1, and 5 times 10 to the 2, because we've got to move it twice. Now, I've put the logarithms for those numbers here. Now, there are two parts to a logarithm. The first part is called the character, and that's negative 1, 1, and 2, and that has to do with the exponent on the power of 10 for our number. The second is called the mantissa, is the decimal. Now, what that decimal is related to is this number right here. What we do is we find the log of 5, that is the decimal, and then we look at the character of the power of 10, and that is the whole number in front. Now, why do we do all this? Okay, so let's go ahead and have a look at these two rules of logarithms. Now, if you multiply two numbers together and take their log, that's exactly the same as taking the log of one and adding it to the log of the other. Likewise, if you subtract the log of one from another, you're dividing that second number into the first. Now, what this does is it basically turns all multiplication into addition and all division into subtraction. And quite frankly, that's the basis of how a slide rule works. So let's go ahead and do a real-life example. Let's take 500 and multiply it by 50. Pretty simple. Now, 500 is 5 times 10 to the 2, so we know the log is going to start with a 2, and it happens to be a 50, and I looked it up a minute ago, so it's 2.698. Now, 50 is going to be 10 to the 1, so it's going to start with a 1, and then it's still 50, and we looked that up earlier. It's the exact same thing. Now, if we add these two together, we get 4.396. Because this starts with 4, we know that it's going to be between 10,000 and 100,000. 96, well, that'll give us the number. And what it turns out to be is 25,000. And that is the log of 25,000. You see how we just added those two together? Well, let's go ahead and do something a little different. Let's divide 500 by 50. What are we going to do differently here? We're going to subtract them. 2.698 minus 1.698 equals 1.00. In base 10, what's a log of 1.00? It's 10. See how easy that works out? Now, if you do this with more complex numbers, ones that you can't do in your head, addition and subtraction in logs still work. And that's, like I said, the basis of the slide rule. Now I want to show you one pitfall, and that is when you're dealing with decimal numbers. So let's go ahead and multiply 50 times 0.5. Let's go see what that comes up to. So we're going to do addition. So we're going to take the log of 50, which is 1.698, and we're going to add to it the log of 0.05, which is negative 1.698, and we get 0. You see the problem there? Now we have a rather elegant way that we deal with this. We fudge the numbers. Let me show you what we do. So what I did was I went ahead and I put the equation up there and I put the character on it as well. So here we have the -1 and we have the 1. Now here's the way we deal with that. So we start off with 50. And then rather than do a -1, what we'll do is we'll do 4.698, and then we'll make a note right here of -5. Now the reason we write this down is when we get our answer, we need to do something with that. So let's go ahead and do this math real quick. So that's going to be 6, that's going to be 9, that's going to be 3, got another one up there, so that's going to be 6. Now, remember, we added 5 to this number. We made a note that when we were done, we had to take it away. So let's take away that 5 and make that 6 a 1. So what's the answer going to be? Well, we know that it's 2.5 times 10 to the 1. And if you multiply 50 by 0.5, you know that the answer is 25. Again, you can use this with very large and very small numbers. You just have to remember this little trick right here. So here we have 3 terms that we're going to multiply. So let's go ahead and go through this. So here we have 2. Now here we have to subtract 1. So now we're back to 1. And here we're adding 3. Notice that we take the 2, subtract that 1, get our answer. Then we take that answer, deal with this one, and we get our answer right here. So our answer is going to be in 10 to the 4. Now there's one more step that we have to make. We have to look at this. 5 times 5 is 25. That's an extra power of 1. Times another 5 is 125. That's a power of 2. So we've got 2 more that we have to add over here. So we're going to end up with 6. Now let's go see if that's right. And ladies and gentlemen, there's our answer, 1,250,000. And that is 1.25 times 10 to the 6th. Now folks, that was a very brief introduction to scientific notation, logarithms, and exponents. Play with this a little bit and try it out. Most scientific calculators have a log function on them. You can find these logs easily. Otherwise, why don't you go ahead and get yourself a slide rule and join us for the slide rule classes on Friday and learn how to do it with a manual computer. So this is Bob the Science Guy signing out from Northern Michigan. Thank you very much for stopping by. I hope you gained a little bit about this. These are some subjects that a lot of people don't pay a lot of attention to. So with the slide rule especially, you have to keep track of the decimal places, and this is a great way to learn how to do it. So take care, folks. Thank you very much for stopping by. Make sure you hit that like and subscribe. See you soon.